Hello, folks. So, welcome to part 17 of learning Rust from scratch. And we're going to be looking at comments and control flow in this video. Most probably just comments, maybe control flow in the next one. So, all programmers strive to make their code easy to understand, but sometimes extra explanation is warranted and is needed. So, in this case, as programmers leave comments in the source code that the compiler will ignore, but people reading the source code may find it useful, right? So, and you can actually do some extra stuff by adding comments and extra information that your tools can use and whatnot. So here's a simple comment. Hello world. So it does not do anything. All right. So in Rust, the idiomatic comment style starts a comment with two slashes and the comment continues until the end of the line. For comments that extend beyond the second line, you will need to include slash slash on each line like this. So we are doing something complicated here long enough that we need multiple lines of comments to do it. You hopefully this comment will explain what's going on, right? No output. And comments can also be placed at the end of lines containing code. I'm feeling lucky today, so but you'll more often see them used in this format with a comment on a separate line above the code it's annotating. So I'm feeling lucky today. So this is how you look at. Rust also has another kind of comment, documentation comments, which we'll discuss in publishing a create to creates section of chapter 14. So let's look at control flow and we should be done. So the ability to run code depending on whether a condition is true and run some code repeatedly while a condition is true are basic building blocks in most programming languages. So it's a control flow. You control the flow of the program based on some conditions. You repeat the code, run some code repeatedly, or run some code based on some conditions. So the most common concepts that let you control the flow of execution of Rust code are if expressions and loops. I think even match expressions are a thing. So an if expression allows you to branch your code depending on conditions. So you provide a condition and then state if this condition is met, run this block of code. If the condition is not met, do not run this block of code. Right? So if the number and create a new project called branches and new projects directly to explore the expression in the source. So you can just run this. So this 3 is less than 5, so condition is true. And condition, there's also an else statement. So all if expressions start with the keyword if, followed by a condition. In this case, you don't even need parentheses around condition. The condition checks whether or not the variable number has a value less than 5. And we place the block of code to execute execute if the condition is true immediately after the condition. So we place a block of code to execute if the condition is true immediately after the condition inside curly brackets. Blocks of code associated with the condition in if expressions are sometimes called arms, just like the arms and match expressions that we discussed in the comparing the yes to the equals number section of chapter 2. Optionally, we can also include an else expression which we chose to do here to give the program an alternate block of code to execute should the condition invalid to false. If you don't provide an else expression and the condition is false, the program will just skip the if block and move on to the next bit of code. Try running the code and you should see the following output. Yeah, you see it. This is it. So let's try running the value of number to a value that makes the condition false to see what happens. So we're changing the number value to 7 and its condition was false. It's also worth noting that the condition in this code must be a bool. If the condition isn't a bool, you'll get an error. So, for example, try running the following code. So this won't run. It'll say error, mismatch types, expected fool, no, sorry, bool found integer. So the error indicates that Rust expected a Boolean rule but for an integer. Unlike languages such as Ruby and JavaScript, Rust will not automatically try to convert an integer or a non-Boolean types to a Boolean. You must be explicit and always provide if with a Boolean as its condition. Uh, so if we want the if code to run only when a number is not equal to zeros, for example, you can change the if expression to the following not equal to zero. Number was something other than zero. So run the code, runs code, and we can running this code will print number was something other than zero. So handling multiple conditions with else if. So you can use multiple conditions by combining if and else in an else if expression, or you can use match. So if number percentage equal to 4, or else if 3, or else if 2, or else. Can you use match here? I don't know. What's the default? How do you say default in Maths? I don't know. This program has four possible, like, is it like Maths is kind of like Switch. So it has different arms. I wonder how do you provide the default arm for this else, last else. So this program has four possible paths it can take. After running it, you should see the following output. So when this program executes, number is divisible by 3, yeah, in this case, yeah. And then it executes, it checks each if expression in turn and executes the first body for which the condition evaluates to true. Note that even though 6 is divisible by 2, it doesn't end up there. We don't see the output numbers divisible, nor do we see the numbers divisible by not divisible by 4, 3, or 2 text on the else block. That's because Rust only executes the block for the first true condition. And once it finds one, it doesn't even check the rest because it's all else, right? So using too many else if expressions can clutter your code. So if you have more than one, you might want to refactor your code. This has a powerful Rust branching concept called match for these cases. Yeah, so we can use match. So because if is an expression, oh, it's an expression. So we can use it on the right side of a let statement. So let number equal to if condition, then 5 else. So there's a value for if, okay, to assign the outcome to a variable. So the number variable will be bound to value based on the outcome of this expression. Run this code and you'll see 5 because condition is true. Remember this that blocks of code evaluate to the last expression in them. So there can be multiple expressions, but the last expression is the one that matters. So, and numbers by themselves are also expressions. In this case, the value of the whole if expression depends on which block of code executes. This means that the values that have the potential to be results from each arm that have this means the values that have the potential to be results from each arm of if must be of the same type. Oh yeah, you can't have something like that makes sense. 5 versus 6.6 or like 5 versus Boolean true. Um, this means the values that have the potential to be results, these are potential to be results, from each arm of this must be of the same type, and listing the results of both if arm and else arm were integer third bits. The types are mismatched as in the following way we'll get an error. So 5 and then 6. So if and else have incompatible types, right? Expected because of which this expected integer found string, right? So compiling branches and if else incompatible types, mismatch types. So um, the expression in the if block evaluates to an integer, the expression in the else block evaluates to a string. This won't work because variables must have a single type, and Rust needs to know at compile time what type the number variable is definitely. Knowing the type of number lets the compiler verify the type is valid everywhere where number is used, the real number. Rust wouldn't be able to do that if the if the type of number was only determined at runtime. The compiler would be more complex and would make fewer guarantees about the code if it had to keep track of multiple hypothetical types for any variable. So, yep, it's tricky. So runtime based stuff it can't do, and here we don't even give the type connotation for numbers. When it guesses the number type, it can be integer and string, then it becomes problematic. It has to check everywhere about what are the different possibilities. And it's an integer, what are the different possibilities? Then it's a string, and will it all work? So the compiler would be complex and would make fewer guarantees about the code if it had to keep track of multiple hypothetical types for any variable. Repetition with loops. So it's often used to execute a block of code more than once. For this task, Rust provides several loops, so which will run through the code inside the loop body to the end and then start immediately back at the beginning. To experiment with loops, provides several loops which will run through the code inside the loop body and the end and then start immediately back at the beginning. To experiment with loops, let's make a new project called loops. Rust has three kinds of loops. Loop, while for, I think do is a reserved keyword, but it's not used yet, but yeah. So loop is an indefinite loop. I think tells us to execute a block of over and over again forever or until you explicitly tell it to stop. So this will keep running. They don't allow to run this code because this will just keep running. When we run this program, we'll see again. Print over and over continuously until you stop the program manually. Most terminals support the keyboard shortcut Control C to interrupt the program that is stuck in a continual loop. Give it a try. So if we just copy this and put it in the playground, I wonder if this will ever stop. So it's printing it again and again and again. I think after some time it will stop. Till then, I'll just type AB something randomly here. AB, is that AB? Oh yeah. So this has already gone really long, and does it even stop? I think it has stopped after some point, or it hasn't. Close fill process. Interesting. Has it stopped? I think it has stopped. Should I just kill the process? I just try to kill the process, but I wonder if they've implemented, measures to ensure that it doesn't run for long. I'm sure they would have done it because, or else someone can just run such an indefinite loop. So that is stuck in a container loop. Give it a try. The symbol caret C represents value pressed Control C. You may or may not see the word again printed after the Control C, depending on where the code was in the loop when it received the interrupt signal. So, fortunately, Rust also provides a way to break out of a loop using code. You can place the break keyword within the loop to tell the program when to stop executing. Recall that we did this in the guessing game layer, indicating after a correct guess section of chapter 2 to exit the program and the user won the game by guessing the correct number. So we also use conmute in the guessing game, which in a loop tells the program to skip over any of the remaining code in this iteration of the loop and go to the next iteration. So returning values from loops, one of the uses of a loop is to retry an operation might fail, such as checking whether a thread has completed its job. You might also need to pass the result of that operation out of the loop to the rest of your code. So result loop counter plus equal to 1, counter 10, then break, or else, oh wait, or else no. Break and then it says counter into 2. So that's kind of like the expressional thing, but that just breaks. I don't know what happens there. So you will also need to pass the result of that operation out of the loop. Students, you can add the value you want returned after the break expression. Oh, break with this value is it? Counter into 2. So when it's 10, just give 20 and the result is 20, I think, after this. So after the break expression, you use to stop the loop. So break semicolon is a statement, but break and then an expression is actually to do this you can add the value. So basically you can add the value you want returned after the break expression you use to stop the loop. That value will be returned out of the loop, so you can use it as shown here. Result is 20. So before the loop, we declare a variable named counter and initialize it to 0. It's a mutable variable, so we say mute. So you will be able to mutate it. So then we declare a variable named result to hold the value returned from the loop. And on every iteration of the loop, we add 1 to the counter variable and then check whether the counter is equal to 10. And when it is, we use the break keyword with the value counter into 2. So 10 into 220. After the loop, we use a semicolon to end the statement that assigns the value to result. Finally, we print the value in result, which in this case is 20. You can also return from inside a loop. Instead of break, you can just say return again. While break only exits the current loop, return always exits the current function. Okay. You would probably just go finally we print the value there. It only exits, not return from inside a loop. Well, break only exits the current loop, return always exits the current function. So if this can be copied and you run this, you get 20. Can you actually say return here? Will it ever print anything is the question. Mismatched types, okay. Expected nothing because of default return type. Found integer. So basically, the main function expected nothing that is the nth tuple or a unit, but expected is but found integer unreachable statement. So after this, there is an unreachable statement of print any code following. So any code following this expression is unreachable. For example, result equal to, and after this is the expression, and this is actually a statement. Your basically this expression. Loop is an expression. So any code following this expression is unreachable. So this is unreachable. So interesting. So you can't just return. It returns a function, so you break the loop. So that's that. Loop labels to disambiguate between loops. Fair. So if you have loops within loops, break and continue apply to the innermost loop at that point. You can optionally specify loop label on a loop that you can then use with break or continue to specify that those keywords apply to the label loop instead of the innermost loop. Loop labels must begin with a single quote. Okay. So it's not go to, it's only for break and continue. So loop labels start with a single quote. So this is the loop labels. So counting up loop, count equal to count, and 0. So remaining 10. And then you have loop, remaining is 10. If it is 9, break, count equal to 2, break, counting up. Break this innermost loop. So is 9, and then this one breaks uh, 9, remaining about 9, 9, break the innermost loop, and then go on and then say 2, and then just copy this. I think it says first count equal to 0, and then remaining 10, and then remaining 9, and then it breaks, and then it's like count equal to 1, and then remaining 10, remaining 9, and then count equal to 0, 10, 9, again break, uh, breaks this, count equal to the 0, 1, 2, 3. We'll keep going on, I think. Oh no, 2, when it's count equal to 2, it will actually see the remaining is 10, but here it will be 2 and it will go out of this. Okay, when remaining is 10, it will still go here, and then here it will be count equal to 2, and then it will just come out. Let's just try that out. So it will count 0, 1, and then till 2 it will count. End count will be 2, and it will be remaining, so count equal to 0, remaining 10, 9. Count equal to 1, remaining 10, 9. Count equal to 2, remaining 10, and then end count 10, 9, 1, 10, 9. Count equal to 2, remaining 10, end count 2. Alright, so interesting stuff. The outer loop has label counting up, and it will count up from 0 to 2. The inner loop without a label counts down from 10 to 9. So 10, and then it stops at 9. This one counts from 0 to 2. So the first break that doesn't specify a label will exit from the inner loop, innermost loop. Like water loop is just before this break. The break counter statement will exit the outer loop. The code prints conditional loops with while. So loop is an indefinite loop. Conditional loops are loops with a condition, and if the condition is true, it just keeps going on. We'll often need to evaluate a condition within a loop. So while the condition is true, the loop runs. When the condition ceases to be true, the program calls break, stopping the loop. It's possible to implement behavior like this using a combination of loop, if, else, and break. You could try that now in a program if you would like. However, this pattern is so common that Rust has a built-in language construct for it called a while loop. We use while to loop the program three times, counting down each time, and then after the loop, print a message in exit. So three, three, and then two, one, zero. We print zero, and this we print one, and then it becomes zero, and that's a 3 to 1. So just say 3 to 1, and then lift off. This construct eliminates a lot of nesting that would be necessary if you use loop, if, else, and break, and it's clearer. While a condition evaluates to true, the code runs, otherwise it exits the loop. So looping through a collection with for, okay, so you have for loop also. You can also use either to loop over the elements of a collection, such as an array. Uh, for example, the loop in this means each element in the array A, correct? 10, 20, 30, 40, 50. The value is 10, 20, 30, 40. Here the code counts up through the elements in the array. It starts at index 0 and then loops until it reaches the final index in the array. That is, index is less than 5. 5 so, is no longer true. So that is when index less than 5 is not. Running this code will print every element in the array. All 5 array values appear in the terminal as expected, even though index will reach a value of 5 at some point. The loop stops executing before trying to fetch a sixth value from the array. However, this approach is error prone. We could cause the program to panic if the index value or test condition is incorrect. For example, if you change the condition of the array to have 4 elements but forgot to update the condition to while index less than 4. The code would panic. It's also slow because the compiler adds runtime code to perform the conditional check of whether the index is within bounds of the array on every iteration through the loop. As a more concise alternative, you can use a for loop and execute some code for each item in a collection. So for every element in a, the value is this. For loop looks like the code in this. So looping through each element of a collection using a for loop, right? So this is looping through each element of a collection using a while loop. So value is 10, 20, 30, 40, 50, similar to that, right? So when we run this code, we'll see the same output in the Symfony code. More importantly, we'll now increase the safety of the code and eliminated the chance of bugs that might result from going beyond the end of the array or not going far enough and missing some items. Using for loop, you wouldn't need to remember to change any other code if you change the number of values in the array as you would with the method used in listing to code. The safety and conciseness of for loops makes them the most commonly used loop construct in Rust. Even situations in which you would want to run some code on a certain number of times, as in the countdown example that use a while loop. Most Rust stations would use a for loop. The way to do that would be to use a range provided by the standard library, which generates all numbers in sequence starting from one number and ending before another number. Here's what the countdown would look like using a for loop and another method is not yet talked about. Reverse to reverse this range. Um, 1 to 4 without including 4, I think 1 to 3, 10, 20, so reverse. So 30, I think the code is a bit nicer, isn't it? Yes. So 3, 2, 1, yes. Summary, you made it. This was a sizable chapter, and you learned about variables, scalar and compound data types, functions, comments, if expressions, and loops. To practice with the concepts discussed in this chapter, try building programs to do the following: convert temperatures between Fahrenheit and Celsius, generate the nth Fibonacci number, and print the lyrics to the Christmas Carol, The 12 Days of Christmas, taking advantage of the repetition in sound. And ready to move on, we'll talk about a concept in Rust that doesn't commonly exist in other programming languages, ownership. So that's all I had for this video. We'll see you on the 18th part of learning Rust from scratch in the next video. I'll see you in the next one. Bye.